How about finding the antiderivative for a trigonometric function? Not quite as step-by-step as for a non-transcendental function, you know, where we have the placeholder and everything like that. But really, what I need to do is go back to my derivative sheet and say, well, first of all, for doing something like this one here, the indefinite integral, I'm going to start with taking my constant and pulling it through the derivative. Through the integral. So -2 integral secant squared x dx. So my function, my integrand, is right there, my secant squared x dx. So I'm going to go back to my derivative sheet and say, well, which one of these derivatives it ends up with secant squared? Oh, and I see that it's tangent x. And actually, if you flip your derivative sheet over, you will notice that the indefinite integral of secant squared x is really tangent x plus c. So they, on this page here, they have the plus c's, which I and maybe you frequently forget. So in this problem here, well, the indefinite integral is going to be -2 times, well, that the secant squared x is tangent x plus c. So I have -2 tan x plus c. How about this one? And I'm going to try and get in the habit of using these parentheses to identify my function. Yeah, I mean, yeah, this is dx, and we know that it's the variable of integration, but you know, it just is. Parentheses are free. Why not use them? So I say secant x tan x. So I'm going back to my derivative sheet here. Let's erase the ones that I did just a second ago here. Where can I find secant x tan x? Right here, secant tan. And the antiderivative of that is secant. So I go back here, and I say, well, I'll call it big F of x is equal to, oh, what was it again? I don't remember. I got to go back. Secant. Secant x plus c. Not so bad. What about something that looks like that? Well, I mean, I might be tempted to go back to my old standby of placeholder and adding 1 to the exponent and all that. But I'm going to rewrite it and see if that helps. Indefinite integral, 2 times 1 over x dx. And I think I'll pull my 2 through. And I have 2 times the integral of 1 over x dx. And that 1 over x is kind of ringing a bell in my head. So I'm going to go back to my derivative sheet, and I'm going to see, is there anything I can see here? Well, there certainly is. Whoops, I just dropped my pen. Hold on a second, there we go. X to the minus 1 is 1 over x, and that has the indefinite integral of log x, or natural log x. Now they have natural log of absolute value of x. I didn't really get into the whole absolute value thing. I don't think you need to get into it either. So the answer to this would be f of x equals ln x plus c. And you're going to have to remember that the relationship between ln x and 1 over x, the derivative of ln x is 1 over x. You don't want to kind of start going through your placeholder stuff. You'll get the wrong answer. How about this one, using e to the x? Well, again, I have a constant. I think I'll just pull that through my integral sign. So the integral of e to the x dx. What function has the derivative of e to the x? Well, e to the x has the derivative of e to the x. So this is going to be 5. Actually, that's a -5. -5 e to the x plus c. Let's look at one that is Also related to logarithms and exponential derivatives, a little bit more confusing. So I want the definite integral of 2 times 5 to the x dx. So again, I'm going to start by pulling my constant through the integral. So 2 times the integral 5 to the x dx. And I have to remember that the derivative with respect to x of a to the x is equal to a to the x ln a. So what this is telling me, and you kind of have to listen carefully, is that when I find the function, the big f of x, whose derivative is going to be 5 to the x, that function is going to have ln a in its denominator. Let me show you why. So my big f of x here is going to be equal to 2 times 5 to the x divided by ln 5 plus c. Let me rewrite that. Because ln 5 is a number and 2 is a number, I'm going to rewrite it as 2 divided by ln 5 times 5 to the x plus c. So forgetting about the c for this, so this is big f of x. Now, if I'll take the derivative of big f of x, so I want f prime of x. That means I'm going to take the derivative with respect to x of 2 over ln 5 times 5 to the x. I can forget about the c because I know the derivative of that's going to be 0. So the 2 over ln 5 gets pulled through the derivative, and then that is times the derivative with respect to x of 5 to the x. Well, that gives me 2 over ln 5, and the derivative of 5 to the x is 5 to the x ln 5. Well, let's look at that over 1, and now you can kind of see these ln 5s are going to cancel out, and my answer is going to be 2 times 5 to the x, which was exactly the function that we were looking for up here. Again, a little bit tricky. I would think this one through, maybe work a couple of additional problems, and I think it'll begin to make more sense.